Can we find out V1 so that V2 equal to 5 volt? That's the question. Let's go find out V1. Solution. In this circuit diagram, you can see this transistor is PNP transistor, and this terminal is emitter, and this is base, and that one is collector. And the another transistor is NPN transistor, and this terminal is collector, and this one base, and this one is emitter. We start out at V2 and work on the way back to V1, one step at a time. Step 1. Since V2 equal to 5 volt, let's find out the current IC2 passing through the resistor R5. So how we can find out IC2? By Ohm's law. We know V2 equal to IC2 into R5, so we just put the value in this equation and rearrange this equation like this: IC2 equal to V2 over R5, and we just put the value for V2. We know V2 equal to 5 volt and R5 is 1 kilo ohm. So finally we found 0.005 volt per ohm, and it makes 5 milliampere. So we have found IC2 equal to 5 milliampere. Step 2. Assume Q2 is in the forward active region, and then now we can find out the emitter current IE2 equal to IC2 divided by alpha F2. And we know that IC2 equal to 5 milliampere, and alpha F2 equal to beta F2 divided by beta F2 plus 1. So 5 milliampere divided by 100 over 100 plus 1. Just beta value we have seen from the first picture, and this is the condition. So for both transistor, beta is equal to 100. So we put the beta value here, then we found 100 divided by 100 plus 1 equal to 0.99, and it makes 5 divided by 0.99 equal to 5.05 milliampere. So we have found IE2 equal to 5.05 milliampere, and it's passing in this direction. Now we can find out VE2 across the resistor R4 using Ohm's law. So VE2 equal to VCC minus IE2 R4. And rearrange this equation: VE2 equal to VCC minus IE2 R4, and we put the value. We know that we just see in this circuit diagram VCC equal to 15 volt, and IE2 we already got it from the previous equation, and R5 is already in this circuit diagram. So we put this value in this equation. We have found like this: VE2 equal to 8.94 volt, and we now found VE2 equal to 8.94 volt. Step 4. Check it out. Q2 is in the forward active region. So if a transistor in forward active region, its collector emitter voltage must be greater than 0.2 volt. Like if VEC2 greater than 0.2 volt, it will be confirmed that Q2 is in forward active region. So we now can write like this: VEC2 equal to VE2 minus V2, and we put the value for VE2 8.94 volt and for V2 equal to 5 volt, and it makes 3.94 volt for VEC2. So it is confirmed that Q2 is in the forward active region as VEC2 greater than 0.2 volt. Step 5. Since Q2 is in the forward active region, its base current is IV2 equal to IC2 over beta F2. We know that IC2 we found from the previous equation, previous step, IC2 equal to 5 milliampere. So we put this value on this equation, and finally we have found IV2 equal to 0.05 milliampere, which is flowing out of Q2. Step 6. Now we want to find out VV2, the base voltage of the transistor Q2. So for that, VV2 is VE2 minus VE2 on. That means 8.94 volt minus 0.7 volt equal to 8.24 volt. That is also Q1's collector voltage, VC1. So I have put this value on this like this. Step 7. Find the current IR2. IR2 equal to VCC minus VC1 divided by R2. So we just put this value on this equation. So 15 volt minus 8.24 volt divided by 30 kilo ohm. As you can see, R2 value is 30 kilo ohm. So we can find IR2 equal to 0.2253 milliampere. Step 8. Find the current IC1 by KCL. So IC1 equal to IR2 plus IB2. So I put this value in this equation, and it makes IC1 equal to 0.2753 milliampere, which I have indicated in this circuit diagram like this. Step 9. Find out IE1 assuming Q1 is in forward active region. So step 9. Find out IE1. Assume Q1 is in the forward active region. So if the transistor is in forward active region, its alpha equal to its collector current divided by its emitter current. So from this equation we can find IE1 equal to IC1 divided by alpha F1. So just put this value now, and we know from the condition of this example the beta equal to 100, so we just put this value beta equal to 100 and calculate, and after calculation we can find IE1 for this. For here IE1 will be 0.278 milliampere, which I have indicated here like this, and then IE1 will flow in this direction. In step 10, find out VE1. Now it's very easy to find out the voltage across this resistor, and that is VE1. So by Ohm's law, VE1 equal to IE1 R3. That means the current in this way and its resistance equal to VE1. So from this equation we can find out VE1, just putting the value like this, and we can find VE1 equal to 5 volt. Here VE1 is 5 volt. I just put this value 5 volt here, VE1. Step 11. Now we check transistor Q1 is in the forward active region. So how we can check this one? If the voltage between the collector and the emitter is greater than 0.2 volt, that means the transistor is in forward active region. So we check it out now like this. VCE1, the voltage between the collector and emitter equal to VC1 minus VE1. That means the voltage from here minus the voltage, this one from here. So from this voltage, if we just minus this much voltage, we can find the VCE1. From this equation, just putting value, we can find VCE1 is 3.2 volt. That means the transistor 1 is in forward active region. Step 12. Find out the base voltage V1, the base voltage from here to here of this transistor. So this is the equation. VV1 equal to VE1, this voltage, plus inside this transistor there is BE is just one voltage for this transistor is 0.7 volt. So the voltage over here should be VE1 plus the voltage over here. So the value, because VE1 equal to 5 volt, and the transistor inside this junction, inside this PN junction, the voltage is 0.7 volt. This is the on voltage. So V1 equal to 5.7 volt we have found, and I have just denoted this V1 just here like this. Step 13. Find out the base current IB1 of Q1. So now it is easy to find out the base current for this transistor. Since Q1 we have found it is in the forward active region, so it is very easy to find out its base current from this equation. Beta F1 equal to IC1 over IB1. We know this equation is very familiar equation. That is, the transistor current gain is its collector current divided by its base current. That's the equation. So from this equation we just rearrange IB1 equal to IC1 divided by beta F1. Just putting this value now, we have found IB1 equal to 0.00275 3 milliampere, which I have indicated here just like this. In final step 14, we will find out the value of this required value for V1. So we have all the current and voltage we have already find out. So now the last stage is to find out the voltage V1. So how we can find out this one? From this equation by Ohm's law. The V1 will be the voltage across this resistor R1, that means IB1 R1, and the voltage inside this PN junction plus the voltage here VE1. So 1 part, 2 part, and 3 part. That 3 part makes the voltage V1, that is in this equation. So V1 equal to IB1 plus R1 plus VBE plus BE1. So just putting this value, because we have already find out the values from the previous stage. So just putting this value, and then after calculation we can find the value V1 equal to 6 volt. So that is our answer. Finally we have found V1 equal to 6 volt. So our answer is V1 equal to 6 volt. That's it. Thanks for watching.